Hi guys, this is Organico Ketones. Today we will be looking at how to determine the four quantum numbers of any element without stress. So as we all know that we have four quantum numbers, we have the principal quantum number, which is denoted as N. We have the Azimuthal, which is denoted as L. We have the magnetic, which is denoted as Ml. We have the spin, which is denoted as Ms. And we all know the functions that the principal is the one that determines the size and energy of an orbital. We all know that. We also know that azimuthal is the one that determines the shape and represents the number of subshell in an orbital. And we also know that the magnetic is the one that shows the direction or orientation of space of each orbital. And we also know that spin quantum number is the one that shows the direction of spin of the electrons in an orbital. So we all know all this already. So today I'll be showing you guys how to do this very fast without stress. So we'll be using this electronic configuration here, and I'm very sure we are all familiar with this. So that is what we are going to be using to aid our work today. So let's look at calcium. Calcium is having atomic number 20, so that will be 1s2, 2s2, 2p6, 3s2, 3s2, 3p6, 4s2. If you check this now, it is 20 already, because 2 plus 2 plus 6 plus 2 plus 6, so it is 20 already. So, and we're having 4s as the last block. So the coefficient of the last block, which is s here, will be the principal quantum number, which is the n. So the coefficient of this s, and which is 4, so that means the principal quantum number is 4. And to get our L, it's very easy also. Look at what I wrote here. I wrote the s, the p, the d, the f. When an element ends its electronic configuration with these blocks, then you are trying to tell the azimuthal quantum number also. When it ends with s, the L will be 0. When it ends with p block, the L will be 1. When it ends with d block, the L will be 2. When it ends with f block, the L will be 3. So, and for calcium, the electronic configuration ends with s, so the L will be 0. So then we are moving up to the magnetic quantum number, which is the Ml. To determine that, we need to know the block of s, and this is the block of s. And if you check here, it's having 2 electrons, so, and 0, because we have to start from 0. So to start this one, we have to start from 0. We can go to this side and we can go to this side, but this one is having only one block, so it is just be 0. So the MO is just 0. And then the MS, since this one is 0, so the MS can either be plus 1 over 2 or minus 1 over 2. Do you understand that? So let's move to iron, which is having atomic number 26. So that will be 1s2, 2s2, 2p6, 3s2, 3s2, 3p6, 4s2, 3d6, because this is 10, this is 10, and then that is 26. So do you get that? So, and as we all know that this the block, okay, the block that is at the end is d block. So the ions with d block, and according to what we have here, is that any element that has its own block with d, the L will be 2. So the L is 2, and we also know that the coefficient of the last block will be the value for the principal quantum number. We know that already, so that one is 3. So, and then let's move to the Ml. So we know that the d block is having 5 blocks. It's having 5 blocks. 1, 2, 3, 4. 1, 2, 3, 4, 5. So it's having. So let's start by filling the electrons. So that's 5. Remaining 1. So the last one will be here. So because the last one. So 1, 2, 3, 4, 5. So we put the 0 here, as I've told you that we are going to start from 0. And this side in mathematics is always negative. So minus 2, minus 1, 1, 2. So, and our last electron fell here. It fell in this first block. And what is under this first block here? It is minus 2. So our ml will be minus 2. So then our ms here, will be. So since this last electron here is facing down, it's facing downward direction. It's facing downward direction. That means it will be minus 1 over 2. Because the ms, which is the spin quantum number, can only have 2 values. It's either you have minus 1 over 2 or plus 1 over 2. So, and those are the 2 possible values for the spin quantum number, which is the ms. Is either it is minus 1 over 2 or plus 1 over 2. So we are through with that. So let's move to the sulfur, which is the third one. So let's write the electronic configuration. So this is 16 already. So this one ends with P, and what is the coefficient of P there is 3. So, and according to this one that we follow here, it says when an element ends with D block, so the L will be 2, as we have said earlier. Yeah, with P block, sorry. So this one, it ends with P block, so it will be 1. It will be 1. It will be 1. So according to what we have here, that when an element ends its electronic configuration with P block, it will be 1. So the L is 1. So let's look at the ML. So since it is P block and P block is having 3 blocks, so let's start filling. 1, 2, 3. So the last one, which is 4, ends here. So 0, 1, minus 1. As you can see, so that means since it's the last electron is ending here, so this one will be minus 1. And since this last electron is facing downward direction, so our ms will be minus 1 over 2. So I hope we are getting that. So let's look at the last one here. I just want to give you this one as an addition. So let's say an element ends its electronic configuration with 4F5. Let's say 4F5. Yeah, let's say 4F5. And we all know that this F block here is having 7 block. So it's having 7 block. 1, 2, 3, 4, 1, 2, 3, 4, 5. It's having 7 blocks. It's having 7 blocks. So let's start putting the electrons. 1, 2, 3, 4, 5. So it didn't finish the something. So and if you look at it, 1, 2, 3, 4, 5. So this is the last electron here. This is where we put it. So let's come to the middle of 1, 2, 3. So this is the middle here. So this will be having 1, 2, 3. This one will be having minus 3, minus 2, minus 1. Do you get it? Do you get the point? This one will be minus 1, minus 2, minus 3. No, I think I've made a mistake. Yeah, I've made a mistake. Sorry. So it will be something like this. 1, 2, 3, 4. 1 2 3 4 5. So you come to the middle. 1 2 3 4. So 1 2 3. So minus 3 minus 2 minus 1 0. So the filling of the electron 1 2 3 1 2 3 4 5. So since it is 4f5, since it is 4f5 we are dealing with, so and the f block always have 7 block. So and since this is where the last one ends, at last electron, so that means okay, let's start with the n, which is the principal quantum number. Yeah, since the 4 is the coefficient here, since 4 is the coefficient here, so 4. And the L, since it is f block, the L will be 3 according to what I've explained. The L will be 3 according to what I've explained earlier. So then the ML will be 1, since this is where the last electron falls, and so it will be 1. So then the MS, since the last electron is facing upward direction, so it will be plus 1 over 2. So that's all that we have today. So please don't forget to subscribe if you have not, so that you can watch more of my videos. Thank you.